two body central force problem. Lecture 2. Theorem 1. Reduction of two body problem 2. Equivalent one body problem. YOX M1 M2 vector R dot 1 CM vector R dot 2 vector R1 vector capital R vector R2. Suppose a conservative two particle system where the masses of the two particles are M1 and M2 at their position vector are R1 and R2. This system has 6 degrees of freedom. In this case, the system center of mass position vector capital R and the relative position vector are equal vector R1 minus vector R2. Each have three components making a total of 6 components. In this case, the kinetic energy of the system is T equal Tc plus T equal 1 by 2 m1 plus m2 r dot square plus 1 by 2 m1 r dot 1 square plus 1 by 2 m2 r dot 2 square. Where T is equal 1 by 2 m1 plus m2 r dot square equal kinetic energy due to the motion of the central of motion of the central of mass. TA equal 1 by 2 m1 r dot 1 square plus 1 by 2 m2 r dot 2 square equal kinetic energy relative to the center of mass. Vector r dot 1 and vector r dot 2 are the position vector relative to the center of mass. And vector r equal vector r1 minus vector r2 equal vector r dot 1 minus vector r dot 2. Equation number 1. We know that in the center of mass from the system is balanced and therefore summation of I mi vector ri equals 0. Summation of I mi vector r dot I equals 0.